division and the inverse of a complex number, or complex numbers actually, of complex numbers, the polar form. So ladies and gentlemen, if you have followed us last time, we have seen the polar form of a complex number, where we have seen that if we have a complex number z, which is equal to x plus yi, its polar form, this is the algebraic form, and we have seen also the polar form. The polar form of this complex number here will be z, which is equal to r, where r is the modulus of the complex number, and times cosine theta plus I sine theta, where theta is the argument of the complex number z, which is equal to x plus yi. So ladies and gentlemen, if we have the polar form as well as the algebraic form of a complex number, we can find also different operation on this polar form. Ladies and gentlemen, we have seen now how we can find the multiplication of two complex numbers in polar form. Today we are going to see now division and inverse of complex numbers in the polar form. I will start with inverse of a complex number, in the polar form. Here, ladies and gentlemen, we are going to consider a complex number z, which is equal to r cosine theta plus I sine theta. So, how do we find the inverse? The inverse of this will be, the inverse is 1 over z. Now, in polar form, if we have to find 1 over z, the formula is given by what? Here we shall see now that it will be 1 over r, which means that we shall find the inverse of our complex number z, the inverse of its modulus first, then times what? Times cosine negative theta plus I sine negative theta. Ladies and gentlemen, we know what it means. Now when we are still here, 1 over z now, ladies and gentlemen, will be equal to 1 over r times what? Cosine negative theta is always cosine theta, because you know cosine of a negative number is the same as the positive number. Whether the angle is positive or whether the angle is negative, its cosine is always the same. And we know that cosine function is an even function. That's why here we shall have again cosine theta. Then, because sine function is an odd function, we shall have here negative I sine theta, ladies and gentlemen. What does it mean? This is equivalent to what is here, and we shall see that simply when we are looking for the inverse of a complex number in polar form, we find the inverse of its modulus, and then to find the argument, it is its opposite. The argument of a complex number in polar form is, of the inverse of a complex number in polar form, equals to its opposite, as you can see. That's why we have here negative theta, and here we have also negative theta. But the modulus is equivalent to the inverse of the complex number z. Ladies and gentlemen, this is the formula we shall be using to find the inverse of every complex number. Now, with this, we can also see what will happen if we are finding the the division or the quotient of two complex numbers in polar form. And that is what we are going to see later on. Let's go on. So, ladies and gentlemen, we are now going to proceed with division in polar form. Here, ladies and gentlemen, you know division exists between two numbers. Either there is a numerator and there should be also a denominator. So we consider here, let's consider two complex number z, which is equal to r1 cos theta 1 plus I sin theta 2, and another complex number w, which is equal to r2 cosine theta 2 plus I sin theta 2. I'm sorry, here it's not theta 2 but it's theta 1 because it was for z, the first complex number. So ladies and gentlemen, now if I'm asked to find the formula to find z over w, which is the quotient of two complex numbers, or the division of two complex numbers, this will be equal to what? This will be given by r1 over r2, which means I find the quotient of the modulus on the moduli, and then I multiply by cosine theta 1 minus theta 2, then plus I sin theta 1 minus theta 2, ladies and gentlemen. So I have here the formula that I will use to find the quotient of two complex numbers. So what do you observe? You will observe that when you are finding the quotient of two complex number, or the division of two complex number, we find also the quotient of the moduli, and we find the difference of the argument to find the argument of the division. So ladies and gentlemen, this is the formula we should be using while finding z over w when you have two complex number in the polar form. Ladies and gentlemen, we should have an example here. If we have like an example here, we have two complex numbers z, which is equal to square root of 2 cosine pi over 3 plus I sin pi over 3, and I have also another complex number w, let's say w, which is also equal to for example 2 square root of 2 factor cosine pi over 4 plus I sin pi over 4. So if I'm to find the quotient, now I will see that it means that here I will see that z over w will be equal to what? Ladies and gentlemen, as I said, we just find the quotient between the ratio between the moduli. Here we have now square root of 2 over 2 square root of 2, which is r1 over r2, now times what? Times cosine pi over 3 minus pi over 4, which means I'm finding just the difference of the argument, plus I sin pi over 3 minus pi over 4, ladies and gentlemen. And now here I will finally get what? Here I have to rationalize this. If I rationalize this, I will multiply by square root of 2 here, and I multiply also by square root of 2 here. You are all used with that. So ladies and gentlemen, I will get here 2 over 2 times 2. Because this, if I multiply by square root of 2, will give me 2 times square root of 2 here will give me 2 times this 2, and again then 2 times 2. Then factor cosine what? Cosine, if I put on the common denominator here will be 12, and I have here 12. Then 12 divided by 3, I get 4. Then here I have 4 pi minus now here 3 pi minus 3 pi over 12 here. Because the table is small, I can use just cis. It's the same. If I have now here, I have 2 over 2 times 3 cis, which means cosine and sine is there, and then we have seen it later. 4 pi minus 3 pi over 12, ladies and gentlemen. And here I will find that if I simplify, I will get what? This will go, and I get 1 over 2, then 6, 4 pi minus 3, which will give us pi over 12. And ladies and gentlemen, this will be the result. This will be the quotient between these two complex number Z and W. Ladies and gentlemen, this is how we find the quotient of two complex numbers in polar form, which is different from how we do it when it is in algebraic form, ladies and gentlemen. So, but you can also come, as we are used for, you can come from polar form to algebraic form. We have seen how we do it later on. So, ladies and gentlemen, this is how we do, and I think you have understood how we do that using this formula, which is here always, and you will be always using it. And if you have seen it, you just find the quotient between the moduli and you find the difference between the argument. Now you get a quotient of two complex numbers in the polar form. Ladies and gentlemen, I can leave you with a small homework that you will do for your better understanding. Thank you. So, ladies and gentlemen, after seeing the formula we use to find the inverse of a complex number in the polar form, and the formula we use to find the quotient between two complex numbers in the polar form, here I will leave you with a small homework. You see here, we shall find, we have Z which is equal to 1 plus I, and we have W which is equal to square root of 3 plus I. I will ask you to find 1 over Z, which is the inverse of this complex number Z. And ladies and gentlemen, for this one, if you reach to the result, you get an answer which is 1 over square root of 2, then 6 negative pi over 4. Ladies and gentlemen, here will be very right, and you should congratulate yourself. And then I will ask you to find Z over W, ladies and gentlemen. Here, if you get an answer which is ladies and gentlemen, square root of 2 over 2, 6 pi over 12, you should have done a great job, and you should congratulate yourself for what you should have done, and you should say that you have understood my lesson today. Ladies and gentlemen, you may need some notes, you may need also some exercises, homework, and the explanation, more details, and the previous video about this. You will visit our website, which is www.umenyi.net, or you can also go to our YouTube channel, ladies and gentlemen, that you find here. It is called Ikaramu TV, and here you get all the previous videos that have passed here so far, and you will upload them, and you can not forget to share as well as to subscribe for you to get all our videos that will be passing. Thank you very much. To our teacher Walter, I love you, and I invite you to love mathematics. Thank you very much. God bless you.